Hi, my name is Andrew Townley, and today I'm going to talk to you about an architecture-based approach to security that we should be taking when we're trying to solve today's security challenges. In particular, I'm going to talk to you about an attack on Ascension St. John, and this was a ransomware attack on a healthcare provider that basically rendered them inoperable in some parts of their system. But there have been many ransomware attacks over the last few weeks that we've seen in the headlines where it's really crippled organizations, and in particular in the NHS, where they had problems matching blood types for surgeries. So I want to talk about something that really, well, it really bothers me in terms of when people hear the words architecture and security in the same sentence. They think that architecture is the infrastructure of your security controls. It's the layout, it's the vendors that you've chosen, it's how they're deployed and put together. And that's certainly a part of it, but that's the outcome. And so today, what I want to talk to you about is much more fundamental, and it's an architectural thinking approach. And if we don't think about these things correctly, then we're never really going to solve these problems. So I'm going to walk you through an architecture-based approach to looking at the ransomware problem. And in fact, this approach is generic. You can apply this to any particular security problem you have. And this is really what makes architecture-based approach to security such a powerful thing. And in particular, we're going to focus on an architecture-based approach to security using the core concepts of SABSA. Let's take a look. Okay, we're going to start with the situation first. So the situation was that Ascension St. John had a cyber attack that was caused by a worker who accidentally downloaded malware. Now, unfortunately, this is something that happens all too frequently. And ultimately, if there is malicious actors out there, they can't really do anything in your infrastructure unless you give them a way in. And the most obvious way to get that way in is to have somebody on the inside download something from the outside that gives them a channel that they can use. This is the basis of every Hollywood movie that talks about cyber attacks or uses cyber as an aspect to move the plot forward, is there's got to be something on the inside that allows the outside to have access to those systems in order to wreak havoc. And this is the pretty fundamental truth of everything that we do in security. It all boils down to access control. The problem is that we don't really understand all of the opportunities that we have to exercise this access control, and that's part of what I'm going to talk to you about today. So basically, we have malicious software, and that malicious software goes from the outside onto your computer. And in this case, it was ransomware, rendered a number of their systems inoperable. It took a few days for them to get back up and running again. And again, this is something we see in the news on a regular basis these days. So let's break it down. Now, in this walkthrough, I'm not going to tell you anything you don't already know, okay? I'm going to say that from the outset. But I'm starting here so that we all come from the same understanding. So if you are an in-depth red teamer and understand how to break into systems, or if you're a blue teamer, or if you're a security architect and have used all these concepts before, what I'm asking you to do is kind of blank slate and put those aside at the moment. And let me walk you through this from a sort of first principles perspective, because we don't all actually have the first principles that are the same. And what I want to show you is that these things that happen to our organizations are actually possible to explain from an architectural perspective. And only through actually understanding them from an architecture perspective are we actually going to be able to do anything about them. So we start kind of in the happy day scenario. There's you, and you control your computer. We have a bad guy. The bad guy is outside and he provides malicious software. And your job is to get your work done, whatever that work is. And it doesn't actually matter what your work is. And from a security perspective, it shouldn't matter to us what your work is, because this comes back to what I believe is the fundamental mission and purpose of security. Mission and purpose of security is to enable the organization to deliver its mission and purpose as quickly and safely as possible. So that is our fundamental remit. That's our fundamental objective. So it doesn't matter where you are in the organization. It doesn't matter what your job is. Our job is to help you get your job done. And outside, there's lots of bad guys with lots of intents and motives and whatever else. And they want to not necessarily stop you from getting your job done, but they want access to stuff that you either have or they think they can access through the access that you have or the systems that you can control. This is the fundamental starting point for any of these situations that we're going to be dealing with. So the first thing that they have to do is the bad guy has to influence you. Because if the bad guy can't communicate with you, they can't influence you. If they can't influence you, they can't get you to do things that they want you to do. And if they can't get you to do things that they want to do, there's no problem. We don't have an attack vector. We don't have any way in because we have blocked the influence path. However, if they influence you successfully, what they're going to try and get you to do is download some malicious software onto your machine. So you click a link, you answer a phishing email, you enter your credentials into some site, whatever it happens to be. But somehow or other, you facilitate the installation of malicious software onto your machine. And once you do that, you have an exploit. Following that exploit, you have malicious software installed on your computer. And what that allows you to do is share control of your computer with the bad guy. So they get what they want, and you might even not know that they're there. And this is part of the problem when we're talking about security awareness, is that, or even as far as the monitoring and the traffic analysis and the things that are trying to say what normal looks like, if your network is already compromised, then normal traffic is, command control traffic for the bad guys as part of normal. So you're not going to necessarily detect things unless you're absolutely sure that your environment hasn't been compromised. And the reality is, in most complex environments, at least with the Global 500 that I deal with in terms of the work that I do to help them implement secure by design or build effective value-driven security programs, it's kind of hard to say whether that's actually true or not, because there's so many machines, there's so many people, and there's so much stuff going on that it's really hard to determine what is legitimate normal and what may be malicious normal. Now, the old school architecture is that we have an enterprise and we have a boundary to that enterprise and we have everything outside. And what we really want to do is we want to keep everything outside and we want to keep everything inside safe. So we're going to establish this perimeter and we're going to maintain this perimeter. And inside the perimeter, everything is trusted. And outside the perimeter, nothing is trusted. Now, this is the sort of, castle model. It's not valid anymore, but you'd be surprised at how many organizations still effectively use this model. So this is one of the reasons that the whole zero trust thing is so popular right now, because it says you can't get away with this model anymore. And even variations on this model aren't good enough because you can't trust anybody. Well, this isn't exactly true. So let's look at why. What we have is a concept of zero trust. Now, zero trust is actually sort of a misnomer. I've talked to John Kindervag on several occasions. He's a great guy. I like him a lot. We have shared views on many, many things. But this whole notion of zero trust doesn't really sit with the notion of trust, because trust is something that's established between individuals. It's not a technical thing. It's a business thing between people. Trust is the result of successfully establishing a negotiated agreement between two parties where each party retains the right to veto. So I may trust you to do certain things, but I may not trust you to do other things. But as soon as I allow you into the realm that says you can do this operation or you can come to my house, that's one thing. But you, just because you come to my house doesn't necessarily mean you can sleep with my girlfriend. So that's part of what happens in my house. But because I trust you for certain things, and I'm very clear about what I trust you for, we can sit down, have a drink, watch a game, watch a movie, have beers, drink wine, whatever it is. But, there are limits to what that trust that we have might be. This is normal. This is a fundamental part of humans. And if you say that there's this concept of zero trust where I don't trust you for anything, then this is a little bit of a problem because people still misunderstand what John Kindervag had in mind. However, the other thing about zero trust that's important for you to know is, well, there's two things actually. One thing is that zero trust really applies only at the network infrastructure. It's a sophisticated way of performing access control, and it's all done at the network level. But that doesn't necessarily need to be the case because while John Kindervag may have done the initial work at Forrester on the definition of what most people know as zero trust between 2008 and 2010, this sort of zero trust concept has been fundamental to SABSA since the very beginning. And you can find it formally established in the Blue Book as far back as 2005. So really, if you understand that it took them 5 years to write this book, it was something that they'd already figured out like in between 2000 and 2005 when the book was actually published. Now, this concept of zero trust is very powerful, but if you're limiting your thinking to the network, you're actually missing the point of it completely. Because what zero trust means is that you have to assert an identity successfully in order to become trusted for some operation. And once you have asserted that identity, then you are actually able to exercise whatever the trusted means in that context, but you have constant trust with everything else that's in that domain. This is one of the fundamental concepts of SABSA. And this is why SABSA is really the only theoretical framework that we can use if we want to talk about security from a perspective we can actually implement. We can actually think about successfully. And if we can implement it and think about it successfully, then we can actually do something concrete to protect our organizations. So what does this look like? Part of the core theory of SABSA is defining this thing called a domain. And SABSA didn't invent the concept of a domain. This was actually something that the ISO security standards came up with back in the day, but they didn't actually really define it. So when John Sherwood was defining SABSA, he defined a domain and said that a domain is a set of elements subject to a common security policy. Now, that's where the SABSA definition starts and stops. But in fact, you can generalize it even more, which I've done as part of the work that I've done since I encountered SABSA back in 2005. And a domain is really any collection of elements that we want to treat for a common purpose that we can identify as having a shared set of characteristics. So this is not incompatible with the standard SABSA definition because the SABSA standard definition says it's a set of elements subject to a common security policy. But if you ask the question why, then you've got to understand that they're subject to a common security policy because they're subject to a common set of risks. Okay, so why are they subject to a common set of risks? Well, they're subject to a common set of risks because they have a set of characteristics that are the same, and or they are using those characteristics for delivery of some business value or to provide some purpose to somebody else. Because otherwise, why would I want to put them in a box and talk about them as a group? I would just talk about them individually, or I wouldn't even talk about them at all. So if you step back and you generalize this concept, What it means is there's a formal basis for every box you've ever drawn on a whiteboard, on a piece of paper, in a document, in a modeling tool, anything else that you can rely on to use because you're grouping those things for a reason. And when you group those things for a reason, it's important. And if you had a standardized way to think about why it's important you're grouping those things, then you've got some powerful things that you can leverage going forward from a security perspective. So let's talk through this. So the first thing is I'm going to introduce you to the concept of a SABSA attribute. Now, the SABSA attribute you may or may not be familiar with, but it's really a definition of a capability or a characteristic that must be delivered, exhibited, shown by a set of elements. So the whole point of establishing a domain is that the domain owner wants to establish and maintain that domain boundary. In practical terms, what that means is they're defining a perimeter for access control, and they are going to set the rules of what can be inside the box versus what can be outside the box. So how does that work? Well, let's say we have an element and it's outside the box. And either that element or us wants that element inside the box because we want to use that element for some purpose, or we want to talk about it, or we want to protect it, or we want to do something with it. But we can't do anything with it unless we have some level of influence over it. And so if it's outside the box, we don't have that. If it's inside the box, we can influence its behavior, or we can protect it, or we can say who has access to it. And this is really the fundamental rationale behind access control. So we want to add it to the domain. Now, add element happens to be one of the 5+ domain events that I've defined in relation to sort of enhancing the standard SABSA concept of a domain, because I find it very useful. I'm not going to get into those right now, but just know that this is one of 5 standard events and then one sort of general event that allows you to talk about how these elements are actually used to deliver business value. So what we want to do is we want to figure out what it takes to get an element from outside into the inside. So the first thing we got to do is we got to identify that element. Is it something that we're interested in, and how do we know? So we got to have a description of the things that we actually care about. We have to, maybe it's properties, if it's beads, maybe it's the color, maybe it's the shape, whatever it happens to be, but it's interesting to us for a reason, and we need to know what that reason is so that we can distinguish the things that we're interested in versus the things we're not interested in. The next thing we need to do is we need to authenticate it to say whether or not it actually meets the criteria we are interested in or not. It looks like a bead, but is it really a bead? Is it made of something that we care about? Is it made of glass? Is it made of, toothpaste? Is it made of sand? Is it made of styrofoam? Maybe we have established our requirements for those things, that we want only glass beads that are of a certain shape, of a certain diameter, and a certain color. So we have those criteria, and the identity of that element is asserted even if we pick it up and look at it, but we need to verify that those things that the element claims are actually present and that it meets our requirements. So that's what this level of authentication is. It is really fundamentally our identity proofing process that we're using to say, can we leverage this element or not? Is it something that we accept? Is it something we want to deal with? Is it something that is worth further consideration? Because if it isn't, then we're just going to reject it right here. So we've gone through that identity process and we put it inside. Now, what are we going to do once we put it inside? Well, we're going to register it, and we're going to say, hey, we are tracking this element as an identity, whatever it is, and then we're going to give it some sort of credential. Now, this credential allows us to not go through that identity process every time, or the identity proofing every time. It's a shortcut. And this is where authentication kind of falls down. And this is really where all of the different extended identity properties come from, because what they're using is things like location or access times or whatever as additional credentials to validate that this is actually an electronic identity under the control of a real world identity that we expect it to be, because that's who we identity proofed in the first place. Now, I can't stress to you enough how important this concept of identity proofing is from a theoretical perspective, not just from an identity and access management perspective that you might be familiar with right now. So again, this is why I asked you to kind of put everything you know to the side for a moment, because these concepts apply much more generally and they're much more powerful than a lot of people realize. So now what? We've got it inside. What does that allow us to say? Well, it allows us to say that, hey, we have a domain, it has some elements, and those elements are available for use for some purpose. Well, what purpose? Well, that's actually kind of up to the domain owner to figure out what that purpose is. But we know we have some elements that meet our criteria, they're under our control, and we can ensure that they're available because we've registered and credentialed them, and we've established a boundary around them that we are actively trying to maintain from an access control perspective. That means we mediate who can interact with our elements, and it also means we mediate which elements can be part of our domain. And inside that box is really the definition of trust, because I have collected those elements for a purpose. And everything that I've gone through and the same identity proofing process has been verified to the same level. Therefore, it is trusted for the same level for whatever it is that I want it to do. So it's not about zero trust. It's about how you are identity proofing the elements that you have so that you're sure that the elements you have are actually the ones you expect to have. And then once you have them and you have control of them, then you can say, hey, I've got these things, they're available for use. Now, why are they interesting and available for use? Well, somebody wants them. Somebody wants them for some purpose. They deliver some value to somebody as either a good or service, or the means of delivering a good or service. So this is what value is. Value is not the good or service. Value is what you can do with the good or service, and value is subjective to the person receiving the good or service that you produce. So you give somebody access to your element, whether it's a glass of wine or a hamburger or service request or access to some storage locations in the cloud, doesn't matter what it is. That is the good or service that you're providing. What that's used for, that's the value, and they're not the same thing. But in order to be of value, it first needs to be interoperable with what the person wants to use it for. If I provide you cloud storage on iCloud and you don't have an Apple ID, then you can't use iCloud. It's effectively useless for you. So it has to be presented to you in a way and exposed to you in a way through some sort of interface that you can actually use in a way that's going to help you deliver the value you expect. The next thing is that you have to be authorized by the domain owner who is managing that access control to use that element for that purpose to deliver the value you expect. This gets into the traditional view of access control once we have access mediated by the domain or your typical IDAM system, because it's about identification, authorization, and authentication for use. But what I'm telling you is that authorization is really just a specialized form of authentication. It's a shortcut in a virtual world for this heavyweight process of identity proofing and credentialing that we've come up with, which is really a limitation of the technology we've used for the last 50 years. Inherently, there's no difference between authentication and authorization conceptually. We have made them different because of the way we have chosen to implement the systems from an efficiency point of view and a technical complexity point of view. Because if I have the key, I'm authorized to go into that room because I have the key. But by presenting that key, what am I actually doing? I'm presenting a credential to the door that lets me in. There's no difference. It's just having an extra dimension of authentication that is based on roles or logical boundaries rather than physical boundaries. So what I've just walked you through is the core theory of SABSA domains with some additions and specific applications of the way I do it. And we've also talked about all of what I call the essential 8 attributes. And every time you draw a box, each of those essential 8 attributes will apply exactly as we walked through them. So that means that you have 8 potential control points that you can use to figure out what security means in any situation, in any environment. Let's see what this means for real. Okay, working from the diagram that we had earlier, we've redrawn things a little bit. We've still got the outside world, and we've got a thing that we're representing as a box now called our enterprise. We still have you, we still have your computer, we still have the malicious software, we still have the bad guy. But what we're going to do is we're going to apply a pattern of decomposition to this enterprise. And that is going to give us a standard set of domains that we can use as part of a multi-tiered control strategy and defining an architecture for how we conceptualize the things that we are talking about within our organization. Now, this is not a document. This is not an infrastructure implementation. This is a conceptual model of the organization so that we can think about how we can prevent this malicious software from getting onto our computers inside our environment. First thing we're going to do is we're going to divide it up into these standard domain patterns. So the first one is people, applications, platforms, data, and networks. Now, these are not all of the standard patterns that I use, but these are enough to help us talk about what we're going to talk about right now. The next thing we're going to do is we're going to talk about the relationships between these domains. Each of these domains has a set of relationships between other domains. And again, there's several actually, even amongst these domains that I've got here. But that's detail we don't need to get into right now. I just want you to understand that each of these domains forms a system, and it is a system defined by the pattern we use to decompose our enterprise into something that we want to deal with and manage. So people use applications. Applications are hosted by platforms. Applications transform data. Platforms store and process data. Data is transferred by the networks, and networks connect us to the outside world. So those are some of the fundamental relationships that we need to worry about. Now, if we talk about what can happen, well, in order for the malware to get into our environment, it has to come across our network at some point. So this gives us one point where we can talk about how we validate the things that come into our network. But what is it that's coming into our network really? Well, it's data. So we can either talk about the connection to our network, or we can talk about the data that is being transferred by that network and potentially have different control points at each one. Now, again, this all plays into our fundamental model, because how do we identity proof the things we allow to connect to our networks? How do we identity proof the data that our networks carry? Now, there's lots of known controls that do these things: filters, firewalls, packet sniffers, all sorts of things, deep inspection firewalls, application firewalls, all those kinds of controls. But people think of those controls as a thing. They think of it as a mechanism that just does a particular thing, but they don't understand the theory behind what we really have in our architecture that gives us the potential to stop these kinds of attacks. Next, you might say, okay, well, we're not really ready for the whole zero trust model, but let's use a traditional deconstruction and decomposition of our network. Well, here again, we can pull another pattern off the shelf that gives us 3 sort of standard domains that we can use to carve up parts of our network. And again, each of those domains has relationships between each other, and each of those relationships and interactions give us potential control points that we can use to, again, apply more and more and more filters to make sure that we are only getting the data that we expect or we want inside our organization. So we might have an internal network and a DMZ and our public internet gateway. So our public internet visibility is our slice of the public internet that we're exposing to the people in our organization, which is a subset of the total public internet out there. That means that if we are going from the public internet, we will need to, again, identity proof to say whether this element could be possible in our DMZ. Can it be added to our DMZ? Yes or no? If that element is successfully added, then are we going to allow it to be added to our internal network? I don't know, but we've got another set of rules. We've got another enforcement point, and we have another conceptual trust boundary that we have established and maintained. And I don't care if you're talking about protect surfaces at the system level, or you narrow it down as, you know, fine-grained as you really want in terms of the zero trust model. Conceptually, it's all the same. It's just how big your protect surface actually is. But we're doing it at conceptual level. We don't have to worry about the physical implementation right now, because our goal is to come up with a security model that actually is something that we can implement and we believe will keep us safe enough to deliver the definition of security that I use. So the definition of security that I use is the degree of confidence somebody's going to have that they're going to get what they want. I mentioned this earlier, but this is a fundamentally different approach to security than anybody else I've ever heard take, because it means that security is inherent to getting what you want. It can't be optional. You don't have security, you're not going to get what you want. Full stop. So it's not something you can ignore. It's not something that you can defund. It's not something that you can, you know, just put on the shelf and come back to later. It has to be an inherent part of how you plan to get whatever it is that you want. And this is what changes the game as far as security is concerned. But you can only really do this if you take an architectural approach based on value delivery. And this is the core of the work that I do with clients right now, because this is not how most people think about security. You can reflect what most people say into this model, but they are not using this model to come up with what it is that they're saying and what they're doing in security right now. Because if they were, we wouldn't have nearly the problems that we have, and we wouldn't have the headlines that we have, and we wouldn't have ransomware breaches like this running amok through healthcare and other industries. It just wouldn't, because we would be able to think about this problem differently. Right now, we don't have the tools to think about this problem differently. And that's what I'm sharing with you today, is a set of tools that help you think about this problem in a way that we can actually do something different. Once the data is somewhere in our environment, then it's going to be an application. Applications are hosted by platforms. How do we allow applications to enter our applications domain? How do we allow applications to be hosted by our platforms? What are the rules here? Now, if you look at the DBIR and you look at what is the fundamental control that you can use, it's application whitelisting, or whatever you want to call it if you're being politically correct. It is about that identity proofing of that application before it executes on that platform. What are we doing there? Because this is one of the most fundamental ways we can do if it gets through all of the identity proofing to get to this point. And once it's there, people use platforms, people use applications, then it's compromised. We can't do anything more. The job has already been done, and we can only react and respond to that situation. All of our opportunities for prevention have been nullified. So what am I talking about here? Well, I'm really talking about a complete system. And that complete system is something that I've been working on really since long before I found SABSA, but certainly since I found SABSA in 2005. So there are a number of parts to this system, but the first one is enhancing the core SABSA domain concept. So I told you about the difference between my definition of a domain and SABSA's standard definition of a domain. Part of that difference involves the association of these 8 essential attributes with the domain formally and these 5 plus events. So the plus event is basically a get out clause for use. So it's add, remove. It's based on the database sort of CRUD model, but in relationship to the special characteristics of domains from a conceptual modeling perspective. Then we have our fundamental governance relationship, which is the delivery of value by a supplier to a customer within an enabling governance domain. And if you are familiar with SABSA at all, you'll recognize that this is a fundamental simplification of every domain relationship that SABSA defines, except the isolated domain, which just hangs in space. So this model allows us to leverage fully the producer product concept of systems thinking and talk about the role-based delivery of value, not the static, finalized, oh, you are the customer, I am the supplier. No, these are not fixed roles. These are dynamic roles based on the exchanges of value, because in any exchange of value or any exchange of goods and services to facilitate that value, there is an exchange in both directions. So these are roles that represent one direction of that value exchange. And this gives us a generic simplified model of trust and governance that we can use in a lot of different ways to help us understand what's really happening in our organization. Whether you're talking about interactions between systems, organizations, people, departments, products, it doesn't matter. This model still applies. And finally, we have a set of reusable and extensible models that are those decomposition patterns that I've found most useful over almost 20 years of my career in doing architecture in the large. I've had a background in solution architecture, application architecture, software systems, enterprise architecture, all of these different kinds of architecture. To me, it's all the same. Security architecture is just no different. And in fact, security architecture is the encompassing kind of architecture exactly because of the definition that I gave you before. If security is the degree of confidence that someone has they're going to get what they want, then the architecture is how you're going to ensure that they get that confidence. It's how you're going to communicate to them what you're doing to facilitate them having that confidence. And all of these things together comprise what I call the Agile security system. There are other parts to it, but this is the parts that we've talked about so far today. And these are really the essential things that are much, much more powerful than even we've talked about today. The more you understand what they are, how useful they are, and how much they give you some concrete theory to enable you to apply systems thinking as the basis of understanding what security means in your organization, the more you recognize that these are powerful concepts. And all of these concepts are fundamentally the 3 core concepts of SABSA that I have taken and enhanced over the course which I've used them and come up with some standard decomposition patterns in the process. So if you found this useful and you kind of get it, or you do get it and you want to know more, or you want to learn what else there is or how else you can think, there's 2 options for you. The first option is you can get a book that I wrote called Getting Started with the Agile Security System. And you can get that book from archistry.club/book. And there's a QR code here. You can download the book. You can get it in ebook form, or you can get a bundle with the ebook and print, or just the print book. But it gives you an overview and an introduction to everything that I've talked about today and how you apply that in the larger process of building security architectures with SABSA. The other option you have is if you're already comfortable with what I've said and are applying SABSA today and feeling a little bit stuck or feeling like you're kind of isolated on your own, you can join us inside the Archistry Club. And the Archistry Club is really a community of people who understand what I've just talked about. We're working to apply this stuff in a way that's beyond standard SABSA, incorporating all of the other aspects that I've pulled into the Agile security system that are enhancements of SABSA, and cross-disciplinary things that I've found useful in being an architect for nearly 20 years. So if you want to join the club and you're interested in seeing what that might look like, you can go to archistry.club and there's a QR code for this. So I hope you found this useful. Again, my name is Andrew Townley. I'm the founder and chief executive of Archistry. And what I do is help large global organizations build effective, value-driven security programs. And I do it all based on this same kind of architectural approach. I don't expose all of it to all the people that I work with because it's not necessary. But my assumption in you watching this video is that you are some level of a security architect, or you are a CISO who wants to understand how they can take an architecture-based approach or apply SABSA more effectively. And I hope you found this useful. And if you have, please like the video, add comments. I will respond to the comments, and make sure you subscribe to the channel because I will be releasing more of these kinds of videos over time as certain things come up that I think are worth explaining. But this is also a sneak preview, I guess, of what I provide every month inside the Archistry Club as a masterclass. They're practical and actionable masterclasses that you are intended to be able to take away and apply immediately after watching them. And you get access to a whole archive of them in addition to joining us to ask me questions live once a month, and access to our private 24/7, 365 Slack community of, again, like-minded architects who are all thinking in similar ways and working to apply this stuff for real. Because let's face it, we need to do some things differently in security today, and we're not going to do it with the thinking we have now. It's exactly the Albert Einstein quote. We're not going to solve today's problems with yesterday's thinking. We need to talk about things differently. We need to think about things differently. And once we think and talk about things, we're going to see things and we're going to do things differently. And I hope you will take initiative in some way or another, doesn't have to be with me, but to do things differently in security, because we need you. We need all of us. Thank you.